All right, so this is a mathematical induction problem. So what we want to do is do all three steps and show all three steps at once. Okay, so we're going to show that this is true for the first one. So 6 times 1 minus 9, is that the same thing as 3 times 1 squared minus 6 times 1? Negative 3 is equal to, yep, negative 3, check. That seems to work out pretty good. I'm going to change colors and thickness on you here, okay? We're going to assume it's true for n equals k. So we're going to say this, negative 3 plus a 3 plus 9 plus yada 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 plus 6k minus 9 is actually equal to 3k squared minus 6k. That's the part that we're assuming. So prove true for the next one. So we're going to have this, negative 3 plus 9 plus yada 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 plus all the way up to 6k minus 9. Now we're going to add on the very next term, which is going to be 6 times k plus 1 minus 9. And we're going to assume that all of that is equal to 3 times k plus 1 squared minus 6 times k plus 1. All right, so now all of this stuff is assumed to be equal to that right there. So I'm going to change colors here so you can sort of follow along, and change thickness here so you can make sure it all fits, right? So now all of this is going to become 3k squared minus 6k, because that's what it's assumed to be, all right? Then we need to add on to that. When I distribute here, I'm going to get a 6k, and then I'm going to distribute there and get a 6, and then a minus 9, and we're assuming that's equal to all this stuff, 3 times k plus 1 squared minus 6 times k plus 1. Okay, so let's clean this up a little bit. I see 3k squared. I see a negative 6k plus 6k. And that's going to go away. So this part here goes away. And then I'm going to have a 6 minus 9 is going to give me a negative 3. Okay? So then I could, I have 3k squared minus 3. So on the other side here, if I take out a k plus 1, all right, what I have left with is a 3 times k plus 1, and then minus a 6, if I do this. Okay, so this ends up being 3 times k squared minus 1. This ends up being k plus 1 times 3k plus 3 minus 6, which is equal to k plus 1 times 3k, and then minus 3, which ends up being k plus 1, factor out of 3, which ends up being k minus 1. Now if you look at this, that's exactly what this says, because this is 3 times k plus 1 times k minus 1, because that's the difference of two squares. Therefore, they are now equal, and we have shown this is true for all integers n.